Good morning. Welcome to the second lecture of this week, where we are discussing about isometric projections as part of this ongoing online course on engineering or architectural graphics part 2. So, in previous lecture, yesterday's lecture, we discussed about how to draw isometric projections of cylinders. Today, we are going to discuss about how to draw isometric projections of cones. We are talking about right angled cones here, and we are in general, when we discussed about orthographic projections or we are discussing about isometric projections, we are talking about regular solids, because it helps us to understand the fundamentals better, how to implement them. Once we are thorough with our fundamentals, we can go on and apply them anywhere. So, today in this lecture, we are going to discuss about isometric projection of cone. Now, cone is, if I have to see, cone is simpler than cylinders and the process remains exactly the same. The only thing being that we have to know where this point of apex is. Once we have located this apex, we will very conveniently be able to draw the cone. Let us see how do you draw that. So, this is a cone which is kept such that its axis is perpendicular to HP and parallel to VP. So, let us take this. So, what I am going to start with is drawing this base. I will make it little bigger, so it is easier for you to see. Okay. So, you can again do the same thing, identify where the centers for the arcs are going to come. So, you identify these centers, the 4 centers, and then we draw the arcs framed by these. So, this is the base, circular base, which we will draw first. This is still rough, that is why I am using this color green. Now, if you look at this, if I have to draw this rectangle which is enclosing the cone in front view. So, this is going to be the rectangle and this was the square. Now, if you see it in the plan, the intersection of these will give us this point which is right below the apex. Now, we have two ways to arrive at the apex. The first one is that we know where the apex is, which is what we have done in pyramids. So, we did the same. You could also be drawing a complete rectangle here. So, we can actually be drawing, which is this, okay, and then we may be needing to extend this. So, the midpoint of this and this, the intersection of that is where the apex is going to come. We could do it this way, that we know where the point below the apex in base is, which is here. We measure the distance which is equal to the height of the cone in isometric, this vertical line, and we would know that this is the point where apex is going to be. That is all that we wanted to know. Now, we will join this point with this curve in such a way that the portion behind this line, the curve behind this line is not visible. That is how we will join it, which is exactly how we had been doing when we were doing the orthographic projections. So, let me now finalize it for you. So, what we have is this. So, we see this front portion, we will draw only up to the point where we see these slant edges coming. Then we draw this slant from the apex joining this curve, and we will draw the rear part of this curve which is coming here. This is very simply this cone which is kept perpendicular to HP, and if you agree, this is much simpler to draw than a cylinder, because there we had to draw two bases. So, one circle in the bottom, the other one in the top, and then we would just join. Here all we have to do is identify where this apex is going to be and draw the base circle, and our job is done. So, this is a very simple position in which we have drawn the cone. We can actually draw any particular position, which is what we will see here. So, this one is a cone where the axis is perpendicular to VP and it is parallel to HP. So, again we will start by drawing this base first. So, assuming that this is perpendicular to VP, we will first draw the base here. So, again I am just repeating the process, though it remains the same. So, how to draw the circle, I am not giving you the instructions, you already know by this time. So, once you start drawing it, you will become familiar with these steps and you would not need any help. Now, this is the point behind the apex in the base. Again the same thing, you could actually take the height of the cone on this line. Now, why are we doing this? In the previous problem also we just took this height. Now, if you look at this axis, you know that this is vertical, this axis is perpendicular to HP and this is where this is parallel to Z axis, one of the axis. So, we know that this height can be measured on this, you have to know. So, that is where your understanding of a 3D would come and that will help you. So, we knew that the height will actually be in this axis, while here we know that this is the third axis where the height is going to be. It is again perpendicular to VP, parallel to HP. So, it is parallel to one of the axis as well. So, we can actually take the height of this cone, whatever that height is, I am just assuming, and we arrive at the apex, and then we will just join this curve with this. This is your final isometric projection for this cone, which is perpendicular to VP, which is kept perpendicular to VP and parallel to HP. So, we will just draw this one, we will just join this. This is the hidden portion of the base behind this, and if you wish you can also draw this axis, it makes it clear. So, this was the axis, and very simply you can see that this picture, this isometric drawing very clearly tells us that this cone is perpendicular to the VP. It could be the other way around, we could actually be assuming that it is kept like this, where the cone is actually parallel to both. So, we would do this again. We will draw the base. For cones and cylinders, we should always start by drawing the bases first. In fact, for all the prisms and pyramids, base is the first thing to be drawn, more so for this because we have curves involved here. This is the point at the back of the apex, and now this time we know that this apex is going to lie on this axis. So, suppose this is the height of this. So, we will just join this. This is how it will be seen, and if I finalize it, I change the color, and if I finalize it here, you can actually see how this is going to look like. Unlike other cases, here we are seeing it from the side of the base. So, there is no hidden line, we are seeing the entire cone together, and this is the axis that we are talking about. So, this is the cone which is kept in such a manner that its axis is both parallel to HP as well as VP. Now, these are simple conditions where we are assuming that the axis is parallel, the axis of the object is parallel to one of the 3 axes. So, it was much easier for us to draw because the base, and it is a right angled cone. So, the base is perpendicular. So, we know that the relation between these 3 axes is this. So, we know it very clearly here. This is 1, this is 2, this is 3. Here we know this is 1, this is 2 and this is 3. So, we know all the 3 axes are coming together here. Now, what if this cone is inclined? Okay. So, we are assuming that in this case this cone is inclined to VP, but it has its axis parallel to HP again, which is what you can see here. You can see it here. Now, we have to draw exactly, we have to repeat the same process, follow the same steps as we used in case of inclined cylinders, and we will start with the base first. So, this is the orthographic projection. I am sure you understand this, and we will start by drawing the identifying the reference rectangles. So, what we have here is this rectangle. So, this is in plan that you see it, and this is in elevation that we have this. Okay. So, now I will start by drawing the plan. So, suppose we have this in the plan. We are just drawing the base first. Okay. Now, if this is the square projection which we are talking about, and okay, so it will be difficult for us to see it here, but then if this is how the this slant line is coming, I should rather change the orientation slightly because we will not be able to see it clearly. I won't be able to explain to you the steps here. So, suppose I assume that it has slightly different angle, and instead of this we get an elongated one, and this is where your the circular base is going to come, and in the elevation we have this. Again, it is going to be very close. But we can still figure it out here. So, this is where the base of the cone is going to come, right. Again, we will do the same things. So, you can figure out where this ellipse is going to come. Okay, this is very tight, but probably you can see. And now, if you join the midpoints of this rectangle, you will actually be arriving at this point, which is the base. But how would you know that where is the apex coming? Because it is a non-isometric line. We do not know where this is going to come. So, what we can actually do is that we can actually enclose this axis in reference rectangles. Okay. So, this is the plan. If you look at this plan, the midpoint, the center of this is where your other reference rectangle starts. Okay. So, we start to draw this reference rectangle, whatever size it is. You can take the actual dimensions here. So, we know that this axis is somewhere on this line. So, this is where the reference rectangle was. This is your axis, I mean in the plan, and this is the apex in plan, and it is at some certain height. Now, what is that certain height is, if we were taking this here, so this height is going to be this. So, we raise it whatever that height given is. This is where your apex is. Maybe I have drawn a bigger here. So, this is where the apex is, and if I take it like this, this is where your apex O is going to come. And now, we can actually join this. I will take a different color and draw the final one. So, what we have here is this, and then the slant coming, joining in the apex, and this part at the back is your dotted portion. So, now you can see that there is a cone which has its base perpendicular. I am talking about the base, not the axis. Okay, I can also draw this axis here. But what you can see here is that there is this base which is contained in this reference rectangle, which is perpendicular to HP, and it is inclined at VP by certain angle, certain degrees. And I repeat it all the time, the angles, the angular lines which are not parallel to the axis in isometric projections, they cannot be drawn. The angle cannot be ascertained. It is not possible. Rather, we should not try doing it. We should be happy with this method where we draw the reference rectangles and convert it into the isometric projection form. So, we have this base which is perpendicular to HP and making a certain angle with the VP, and then there is this axis which is perpendicular to this, and we arrive at this with the help of this reference rectangle. It is very simple if we continue to follow these examples where we just have to arrive at any point with the help of these reference rectangles. We can draw the isometric projection of any object for that matter. The only thing, the only caution here is that these reference rectangles are all related to each other. They have to be in reference to a line, to a certain line. So, what we are assuming here is, if I can draw, I will take a different color. This is the line which we are talking about. Okay. So, this is the reference line, this is xy, this is this reference line which we are talking about. And when we draw the plan, you can assume anything. Okay. You could actually be taking it here or there, wherever, but you keep it consistent. So, if we are seeing it like this, this is the reference plan, reference rectangle for this circle. Okay. Now, this reference is going to be in continuation in reference to the one that we have already drawn and the reference that we have already taken. This is actually not the xy line, but just to understand, this is the axis. So, if we look at this, this is z, this is one of the axes, and this is the third one. This is how we are assuming these three axes to be coming. It is totally up to us how are we assuming the three axes to be coming together, but we know that in isometric projections they will actually be making these 60-degree angles, which is between the three axes, which is what we will see all the time happening. So, looking at that, we can arrive at any point. You can individually arrive at a point, you can arrive at a line. So, we could actually be deriving where this axis is going to come. So, if we draw just this reference rectangle here, so just this reference rectangle, and so we would have this. So, we would have this line which is at a certain height. So, we can actually draw this reference rectangle, we get this line, we raise it and we get this axis. We can actually do it this way. So, we can draw lines, we can draw points, we can draw planes and overall 3D objects following the same methodology, so following the same procedure. So, just be very firm with the steps that you use, and then you will be able to arrive at anything. I will give you one more example of cones. Now, here this we have done through orthographic projections, where the cone is lying on one of its generators in HP. Now, here it is a simple condition. This is not a doubly inclined cone, it is a singly inclined cone. So, what we see here is that this axis is actually parallel to VP, but it is making a certain angle with the HP. So, what we are going to do is, okay, I will mark the xy axis here. So, it will make it little easier for us to apprehend. Okay. Now, we will do it again. So, what we have is, we have this and we have this in the plan. So, this is the rectangle that we have in the plan at whatever distance. So, what we have here is, say, I will enlarge it a little bit. So, this is the rectangle in the plan, and in the elevation we have approximately the same thing. Okay. Right. So, if we see it in the front, you know that this is we know that this is the plane where your base of the cone is going to come, right. Now, we can mark all these points. So, this is where one of your points is going to come. This is approximately where your middle points on this is going to come, and approximately here we arrive at the projection of this base, and this is approximately what you will see. Okay. Exactly the same process we can take 12 points. Okay. So, we can actually take 12 points like this, horizontal distance, all the 3 points, their distances, or we could try doing it with the help of identifying the centers and the radius, which in case of non-isometric ones might not work. So, the 12 points formula will always work, which is what we can apply here. Now, we have to identify where the axis is going to come. Okay. Now, if you look at this axis, which is here, this line. Okay. So, it is actually coming from, this is here, and you draw a line which is parallel to x y, right, somewhere here, assume that this is parallel. So, whatever the height, whatever the length of this axis is, we can just measure it here. This is the apex and this is the base. Isometric projection couldn't be simpler. So, we already know this, we have to just join this and this. So, this is what you will actually see. I will change the color and I will just draw the final projection. So, if you look at this, this is the slant joining the apex. Very simple. And you can also arrive at the axis, which is this line joining the apex to its projection point in the base. This is the axis. It looks little skewed because we are seeing it from this side where the base is more visible, but suppose it was kept the other way around where your axis was perpendicular. So, it will actually not be perpendicular, but it will be doubly inclined probably, but where if you look at it in the plan, it was perpendicular to the VP and making a certain angle with the HP. It will actually be making a certain angle with VP as well, but just assume that this entire cone is rotated like this. So, we would not be seeing the base directly, we will be seeing more of the conical part, the surface of it, and we can still draw it very conveniently if we just know where this axis is coming. We know the reference rectangles, how to draw these reference rectangles, but reference rectangles can only be drawn for planar surfaces where we know what that plane is which we are talking about. So, we can create these reference rectangles for the same plane. Now, you can't create this a reference plane for this conical part because it is not a plane, it is a 3D surface. However, we can do that if we were talking about the pyramids. So, what happens in the pyramids is that you have these individual triangular faces. We can identify any one of those triangular faces and start drawing its reference here, these reference rectangles here in both plan and elevation. Now, if when I have drawn this reference line, probably things are much clearer that in reference to this reference line, we will draw these reference rectangles and then arrive at whatever planes we are talking about, and they will all match. So, isometric projection is as scientific as orthographic projections. We can still arrive at all these points provided we are following the scale 1, any scale. You could scale up the drawing, you could scale down the drawing, but we have to take the projections just as we take the orthographic projections. The only thing being the reference rectangles have to be made. So, that is all in isometric projection for cones. We will continue our discussion on isometric projection with other types of solids in subsequent lectures. If you have any query, if you have any doubt, kindly write to us and please practice at your home using proper stationery. I hope you are following up on the concepts. Thank you very much for joining me today. Bye-bye.